Okay, you're welcome once more to our chemistry class. This is the Supernovas TV. If this is the first time of coming across a video, kindly give us subscription. Just subscribe. Okay, so you will have access to more videos. In this class, we are going to discuss chemical equilibrium. Okay, scientists that worked on equilibrium is the Chatelain, where he discussed the effect of changes in pressure, temperature, concentration, and also catalyst, although catalyst has no effect on the equilibrium constant. But he discussed the effects of these changes on the equilibrium position. So we're going to discuss that using this equation. This equation is the Haber process involving formation of ammonia. Okay, this is a Haber process where we use iron as catalyst to produce what? Ammonia. Okay, this is nitrogen, this is hydrogen, and this is ammonia being formed here. Okay, delta H equal minus 90 kilojoule tells us that is an exothermic process. This is an exothermic process, that is, heat is given off to the surroundings. Okay, now we'll take note that 1 mole of hydrogen here is reacting with 3 moles of 1 mole of nitrogen is reacting with 3 moles of hydrogen to give us 2 moles of ammonia gas. Okay, I didn't put all this. Okay, there's a gas here and there's a gas here. Effect of temperature. What happens if temperature is increased in this system? Okay, increase in temperature. Remember, this equation or the reaction is an exothermic reaction. So in other words, it already has high temperature in it. So if we increase the temperature, the reaction will not go forward. The reaction goes backward because it is an exothermic reaction. And due to that, we have already excess heat given off to the environment, making the environment warmer. So if we increase the temperature here, the equilibrium position will shift backward and favor the reverse reaction. This would not be the case if this were to be an endothermic reaction. If you had delta H equal to plus, okay, positive, increase in temperature will favor the forward reaction. But since this is an exo, increase in temperature will reverse, okay, will move the position backward. And then if we decrease the temperature, this is effect in temperature, please, effect of temperature, decrease in temperature. So if we lower the temperature of the medium, decrease in temperature will favor the forward reaction. Okay, I hope you got that. Now, what about pressure? This is about temperature, take note. What about pressure? Okay, in terms of pressure now, we're looking at number of moles of reactants that will lead to number of moles of products. Okay, if we check here, let's look at, I'll rub this off, so we'll look at effect of pressure. Okay, now pressure. What will happen if there's increase in pressure? What would happen? Increase in pressure. Take note that from the reactant side we have 4 moles. That's what I have taken note of. 4 moles of reactant is giving us 2 moles of product or volume. You can say volume of product. Now what this does is that already there is increased pressure here, and the pressure here is reduced because you have 2 moles only. So if we increase pressure, in order to maintain the low pressure exerted here or experienced in the product side, the equilibrium position will shift so that the pressure will be maintained across reactant and product side. So if we increase the pressure here, we can see that the equilibrium position will shift to the right. Okay, because any change is to make sure that the it annuls, okay, the equilibrium position, shift the direction so as to neutralize the change. Okay, so if we increase the pressure here, it moves to the right where there is low pressure, okay, such that the reaction remains in equilibrium. Meanwhile, if we decrease the pressure, there is already increased pressure here. So if we decrease the pressure, okay, the equilibrium position will shift backward. Will shift to the left or reactant side. Okay, take note that in terms of concentration, once the concentration of reactants are increased, the products will also be increased. Therefore, if we increase the concentration of nitrogen and hydrogen, the equilibrium position will shift to the right to favor more product formation. And if we reduce the concentration, the equilibrium position will fall back. Okay, in other words, we'll have less product formed and the reactants just go on. Okay, now about catalyst. Catalyst has no effect on the equilibrium position. Catalyst just alters the rate of the reaction and makes the reaction to occur in a shorter time. Okay, and then those are some basic factors. And then we also have the equilibrium constant. We can express this. Okay, let me rub this off. And then let's have the expression of the equilibrium constant. Those are the basic things you need under this equilibrium chemical equilibrium. So equilibrium constant, okay, we can have that as that's product, okay, raised to the power n, whichever product over reactants raised to the power of n. Okay, number of moles is n. So in other words, we have this as the product here is ammonia. So we have ammonia, okay, raised to the power of 2 because of 2 moles divided by, okay, nitrogen. Nitrogen is just 1 mole of nitrogen gas. Okay, that's 3 moles of hydrogen gas. Okay, hydrogen, that'll be 3 moles here. So that's the expression for equilibrium constant. Okay, although we use this for only gaseous and aqueous medium. Okay, so that's all about this topic. Thank you for watching. I'll see you in the next class.